All right, people. Anthony Marshall here, Leatherneck Precision Machine. And we're going to demonstrate this faro arm. This is the arm itself right here. It has 6 rotational axes, as you can see. It's got a little ball on the front. These probes are actually kinematic, where you can take it off, put another one on there, and it stores the calibration data right here inside the probe. So when you use it, you don't have to calibrate it every time. So what we're going to do is demonstrate what this is for, and we're going to go through it. So this is a part that I did for Boom Supersonic quite a while ago. This one's actually scrapped because there's a problem on the backside where the tool crashed into one of the ribs. So I didn't, can't send it to them like that. Especially when this is an antenna mount and it goes on the outside of the airplane. So we just made another one. So anyways, what we're going to do is we're going to align this part with the computer model of it that's on the computer screen there. We're going to use those little target looking things to do it. So we're going to run here, we're going to run this thing called auto align. Now we're going to pull the arm out here. Sometimes it does, I don't know why it does that, but sometimes it takes a hit before you actually take a hit. So we just undo it. We put it here, press the green button, tells us to go to the next one. Push the green button, tells us to keep going to the next one after we hit it. So we're hitting this little green button to get this thing aligned to the computer. So once we do that, this little box comes up and tells us, what the deviations were and if it's good. It's got all green check marks, so it's good. We're going to accept it. Now it's going to go into inspect. And we're going to take some points on the surface and we'll show you what that looks like. And so here we go. We're going to take a point right here. You can see the probe on the actual computer right there in the same location that I put it, because now this part and that part on the computer match. So here we go. We take a point there. And it's telling us, it's showing us that it's green. It's showing us the deviation there at the bottom of the screen. Kind of see it better. And I'll always show the last point with the arrow like that. Now as long as this little ball is in contact with the surface, it's getting an accurate point. So as you can see, it's putting all these arrows. If you zoom in, you can see the arrows and which way the deviation is going. And you probably can't see it on your screen, but it's telling us in these little boxes what the actual deviation number is, how far it is. And it's showing us about 3 to 4 thousandths difference. But I didn't have this when I made this part, so I didn't inspect it a different way. If I would have had this back then, those would have been a lot better, but it's within tolerance still, because it was, I believe it's a profile tolerance of plus or minus 30, which is quite a bit. I mean, I got it within 4. So here's another thing we can do. We can zoom in here, and we can put this into continuous mode. Now, instead of hitting the button each time, we can just hold it down. And it's taking a bunch of points. See all those points it's taking? It's taking about 4,000 points already. So that's telling us, if it's all good. There's a lot more you can do with it. Like you can go in here and say, I need to know, I want to go into create a plane. Create a plane and go 1, 2, 3, 4. Oh, we got it in continuous mode still. So we're going to go back to single point and we're going to say create a plane. Create a plane. When I get to the last point, the fourth point, it's automatically going to create the plane for me. So now we're going to create a plane on this. So now we have those two planes, right? You can see them on the screen. We can actually go like this and say we want to create a report, and we want to take data, those two hits, and we want to see how perpendicular they are. Are they perpendicular with each other? Nominal is 90 degrees. It measured it at 89 degrees, 0.9695, which is well within tolerance. That's only like, maybe a couple, like a second or so. So we know that it's good. And then when we're done, we can hit the report button down there and it'll create an inspection report for us. And we can send this to our customer and they know, oh, he inspected it with VeriSurf and some type of CMM, and they can be like pretty assured that our part's good. Now they're probably still going to inspect it themselves, but this gives them a lot more confidence in what we're doing here. So that's just a basic little demonstration. You can do a lot more with it. Like eventually, I'm going to be building a chopper for my wife over the next couple of years probably, because it's going to take a while. This is the primary case off of I have a 1966 Triumph T120 motor from the 1966. But this has a little crack right here, and this is filled with oil when the bike's running, so that would probably have a leak in it. And I don't want to weld it up, so eventually I'll take this and I'll glue it down to the surface, and I will take all the point locations for all these holes, all these heights, and I'll be able to reverse engineer this and make a completely brand new one with my own styling to it. I can create the part the way I want it to look. I won't have to make it look like the stock one. I can make it look totally different, like make the Triumph logo bigger and kind of flow with it or whatever. I can do whatever I want. So that's a basic demonstration of the Faro arm for you. Hope you enjoy.